Okay, let's take a look at number 1 in section 6.1. We're going to talk about finding the points or the x values where the graphs of two functions intersect. And this is a part of a multi-step question, numbers 1 through 3. This is the first one. And really, this is where you need to start when you're finding the area bounded by two or more curves or two or more, the graphs of two or more functions. You want to find often the points of intersection. Read carefully. They want you to round the solutions to 4 decimal places, and then they do not want you to perform any intermediate rounding. So you want to get the exact solution and then approximate that with your calculator. And we'll show you how to do that. So first thing is to find the points where the graphs of these two functions will intersect. We'll just equate their outputs, or of course their y values, the vertical height. When is the height of these two functions the same? So I'm going to let g of x, right, which is this function, equal f of x. When are these two outputs the same? So I have to solve this equation. You can see this is when I multiply this out, I've got a quadratic equation. So we're going to get a couple solutions here. And so let's go with it. Let's expand this out. First of all, x minus 2 squared will be x squared minus 4x plus 4. Right, remember that's x minus 2 times x minus 2, so we FOIL that out. 4 plus 4.5 is 8.5. Okay, and now I'm going to set it equal to 0. So to do that, I'm going to add 2x to both sides. So negative 4x plus 2x. And then I'm going to subtract 35 from both sides. Okay. Now, in this form, you can use the quadratic formula. Since the coefficient of x is 1 and the coefficient of x is negative 2, which is pretty nice, I'm actually going to show you how to complete the square. The quadratic formula actually comes from completing the square. So how do you complete the square? Well, you add the 26.5, and then you want to complete the square on x squared minus 2x. And you see I've done that. How did I do that? Well, remember, x squared minus 2x, you can make it a perfect square if the constant is what? You take half the coefficient of x, half of negative 2 is negative 1, and you square that and you get positive 1, right? That's going to complete the square. Of course, if I add 1 here, what do I have to do here? I have to add 1 here. So here, 26.5 plus 1 is 27.5. But this now is a perfect square, and it factors right as x minus 1 quantity squared. And I can solve by doing what? Taking the square root. I do have to include both the positive and negative roots. And then I can solve for x by adding 1. And so I get two solutions, one minus the square root of 27.5 and one plus the square root of 27.5. And I did that on the calculator because they did want you to round that to 4 decimal places. So here, the negative 4.2440, since that next digit after the 0 is a 4, I'm going to keep it at 0. If this digit was 5 or bigger, I would, of course, round that up to a 1. So be careful. Your numbers might be slightly different than the ones I have here. And then 1 plus the square root of 27.5 is this, rounded to 4 decimal places is this value here. So there's the solution. Now, if you did the quadratic formula, that's fine. Of course, the value, you would use this equation. Remember, ax squared plus bx plus c equals 0. In that case, x is equal to, this expression here. And value of A here is 1, B is negative 2, and C is negative 26.5. So I plug those values in, simplify, and you can actually at this point use your calculator to approximate. Is this right here the same as this? Well, I show that it is because 110 is 4 times 27.5, and the square root of 4 is 2, so I get 2 times the square root of 27.5. And then notice I can divide everything, both of these two terms by 2, right? 2 divided by 2 is 1. 2 root 27.5 divided by 2 is root 27.5, just to show you that indeed they're the same. Quadratic formula is nice, but if the coefficient in front of x squared is 1, I'll typically complete the squares. It's a little bit easier than having to at least simplify if you need the exact answer. At any rate, that's how you would find the points of intersection. Questions 2 and 3 then, carry this on. How do you then find the area bounded by the graphs of these two functions? All right, I hope this helps.